Hello. Hello, students. Mahmood. Hello. 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 Alaikum salam. Mahmood is there? Mahmood. Okay. We have going to continue the class. Yesterday we have completed 3 properties of beta function and 5 properties of gamma function. One more property of the gamma function is left off. That now I am going to complete. Before that, 6th property, we have a relation to prove. Very important relation. So I am doing now today relation between beta and gamma function. Relation between beta and gamma function. Beta and gamma function. Relation between beta and gamma function. It's a very important, and surely you may get it this question. It is the relation between beta and gamma function. So we start our session today with the help of this relation now, and this relation is also useful to prove next the 6th property. Mr. Mukarram, you can switch off your camera. Okay, now I'm going to start now. Actually, we have to prove that in this relation, we have to prove that beta of m comma n value, beta will be represented with this only now. Beta of m comma n is equal to gamma of m into gamma of n and divided by gamma of m plus n. This is the relation between beta and gamma function. We have to prove this one. So now how it will be the proof working, you see. We start proof. So as I told you, very important proof. Definitely you will get in exam. Okay, see, we start working on this proof. So I am taking the help of the gamma function definition by definition of gamma function by definition of gamma function. You remember what is the gamma function definition? Anyone? Come on. Gamma of n is equal to
integration of 0 to
exactly, very good. Integration of 0 to infinite. Come on. E to the power of minus x and x to
power
the
n minus
very good x to the power of
dx.
n minus 1 into dx. This is our first property, beta and gamma function definition. Okay, and now also third property, you see the third property of gamma function we proved yesterday. This one, gamma of n is equal to z power n integral 0 to infinite e to the power of minus zx x to the power of n minus 1 into dx. This is taken as equation number 1. This is actually gamma function definition. This is the third property of gamma function. Gamma of n is equal to z power n integral 0 to infinity e power minus zx x power n minus 1 into dx. So what I am doing here, I am going to do some simplification of this equation number 1. These multiple terms z power n, we can divide this side. So this is gamma of n. The multiple terms comes to the denominator. So it will become z to the power of n here. It is equal to integral 0 to infinite e to the power of minus zx e to the power of minus zx and x to the power of n minus 1 into dx. Okay, this is taken as the second equation. Okay, this is the second equation. See what I told you in the definition of gamma function. If we change here the value of n, this value of n definitely affect here this value of n, this one. If I am writing m here, the m will come here. If I am writing p here, the p will come here, x to the power of p minus 1. And you can change the variable also. इसको आप चाहे तो gamma of n is equal to integral 0 to infinity e power minus, instead of variable x you can use a variable y also, that is also correct. You can use the variable z also, e to the power of minus z, and z to the power of n minus 1 dz also we can write. And choice is yours. N can be changed, it is possible. X can be changed, it is possible. Okay, and but the infinity, this limit should not be changed. अगर आप यहाँ पे m करें तो infinity में कुछ भी effect नहीं होगा. Okay, understood this point? You remember gamma of n value x power n minus 1. The changing of n is possible. N can be replaced with m also, p also, k also, t also. Variable also we can change with respect to x, with respect to y, with respect to z, depends upon your choice. This is the third property. What I did, there is a small simplification in the third property. So now regular work will be continuing. What I am doing here is, you see, multiply equation number 1 by, so what I am doing, you see, equation number 1 को मैं gamma function की definition के फॉर्म में बना रहा हूँ. So multiplying equation number 1 by z to the power of m minus 1 z to the power of m minus 1 e to the power of minus z and integrate with respect to z, integrate with respect to z, and from we have to take the limits also. So the limits from 0 to infinite, So what happened, you see, when I am multiplying equation number 1 with this e to the power of minus z and z power m minus 1, and when I am integrating from 0 to infinity dz, so what happened to this left hand side, you can see So this is gamma of n must be as it is. Now we start our work, that is integral 0 to infinite. Okay, e to the power of minus z, e to the power of minus z, z to the power of m minus 1, z to the power of m minus 1, dz is equal to, okay, this side is over. Now this side we have z to the power of n, but since we are integrating with respect to z, we do not consider z as a constant, so z must be and should be inside the integral. So I am writing now, this is integral 0 to infinite, that we are taking that e power minus z we are multiplying, and z to the power of m minus 1 also as it is. Okay, and that dz part I will write it here. Remaining, what are the values already available here, that I am writing as it is, that is 0 to infinite, e to the power of minus zx, e to the power of minus zx, and x to the power of n minus 1, x to the power of n minus 1 into dx will be as it is, a bracket close. Till here any doubt you tell me? देखिए अपन क्या करें, first of all we are using the definition of gamma function, then third property of gamma function, there is a small simplification, then actually in the right hand side I want to write gamma of m value. For that purpose what I did, I am going to multiplying e power minus z, z power m minus 1, and then integrating with respect to z from 0 to infinity. So this part, what is this part becomes, now tell me, this gamma of n as it is, what is this part becomes? If you compare with the definition, what we can write here, gamma of m, that is why we did this much of work to replace this value with gamma of m. What I said, gamma of m, and वेरिएबल चेंज हो सकता बोला ना मैं अभी आपको, x भी हो सकता, z भी हो सकता. So यहाँ पे देखिए आप, वेरिएबल x है gamma of n, but here the change is m, so we should write it as gamma of m. This is equal to, here what we will do it here is, we can multiply, we can equate the like terms and rest of the terms. You see, when we are going to multiply this and this, can we say that the bases are equal and power should be added? Possible now here? Give me the answer.
Cheese.
Yeah. Similarly, we have one more z power m. I think we missed that. I'm writing here. Z power n एक अपन miss करें वहाँ का. ये z power n. Again, these two also bases are equal. Power should be added is possible. So here 0 to infinity. Here also 0 to infinity. Together we can write 0 to infinite. This is also 0 to infinite. Okay. Now when we add these two, e power minus z, e power minus zx, e to the power of, if you take minus z common, it is becomes 1 plus x. It is becomes 1 plus x, and when these two z's powers are added, here it is becomes z to the power of m plus n minus 1, m plus n minus 1, and this x to the power of n minus 1 as it is left off here, x to the power of n minus 1 as it is left off here, and dx also as it is, even dz also as it is. Okay, then later on, by change of order of integration, change of order, I am applying this one here, by change of order. अब आप बोलेंगे सर चेंज ऑफ ऑर्डर तो बहुत बड़ा प्रोसेस है, यहाँ पे मैं चेंज ऑफ ऑर्डर के लिए क्या कर रहा हूँ, ओनली एक्स टर्म्स और डी जेड टर्म्स को सेपरेट कर रहा हूँ, ओनली separating the x terms and the z terms. Gamma of n is equal to, what I am doing here, you see, integral 0 to infinite, yeah, x to the power of n minus 1 is a separate term, and for this we have dx, and then remaining terms whatever we are having, that we have to write. So what is left of 0 to infinite, e to the power of minus z into 1 plus x minus z into 1 plus x, z to the power of m plus n minus 1, m plus n minus 1 into dz. So this is what we did by change of order. X के terms को along with the dx we wrote, and the terms of z along with the dz we wrote. So finally, gamma of m into gamma of n is equals to, this is equal to integral 0 to infinite will be as it is. Okay, x to the power of n minus 1 also as it is. Now you notice this term. This one we should compare with this one. Equation number 2 को और ये equation number 3 को एक बार notice करिए. Just see the difference between equation number 2 and equation number 3. First, I will explain what is equation number 2. See, whatever the term here, variable is x, here the variable is z. Forget about the variables. Okay. And now you see, here power is n minus 1. That's why here numerator is gamma of n. But here what we have the power? M plus n minus 1. So what will be the value here? Numerator value. Numerator value will be, first of all, gamma of m plus n by denominator. Now you see the denominator. Here denominator is z power n. When x coefficient is minus z. यहाँ पे देखिए, x coefficient is what? यहाँ पे z coefficient is 1 plus x. So it will becomes 1 plus x whole to the power of m plus n, and here bracket close, this bracket close, and then this dx, this part is over, this dx is as it is. अब आप याद करिए second property of ये multiple terms comes to the denominator with you see this multiple terms comes to the denominator. It is gamma of m, gamma of n, multiple terms comes to the denominator, so gamma of m plus n is equal to, yeah, whatever it is left, 0 to infinity x power n minus 1 by 1 plus x power m plus n. Actually it is the second property of beta function. You remember second property of beta function की value देख लीजिए एक बार. This is beta of m comma n. So like that we proved gamma of beta of m comma n is equal to gamma of m into gamma of n by gamma of m plus n. This is very, very important relation between beta and gamma function. If you understand this relation, then only we can prove the sixth property of gamma function. And in exam, definitely any one will come, either relation or that property. Gamma of 1 by 2 is equal to root pi. That's the important question. And if you see the last year paper, 2022 April paper, this question is there. Relation between beta and gamma function. So you note down this one, then we'll go for that property. Gamma of 1 by 2 is equal to root pi. Hello, Mahmood.
जी sir.
Why you are not giving any answer? Yesterday you are not there now.
I was there, sir.
But silently you are sitting.
Yeah.
So 43, 44. Do you have any doubt in this? All three sisters. No doubt?
Excuse me, sir.
Yeah, who is that?
The last step.
Last step, okay. Which last step? This one?
Yes, sir.
You see, what is the difference here? Just compare this part of the equation number 3 with equation number 2. ये इन दोनों को compare कर लीजिए आप, आसानी से आंसर आ जाए. Variable here you have z, here variable you have x. Forget about the variable. Variable may be anything. It may be x, it may be z, it may be y. Forget about it. Now what I said, whatever the value it is available here, यहाँ पे अगर n है तो यहाँ पे न्यूमरेटर में n आता, यहाँ पे अगर m है so then you will get m here. But in our equation number 3, what we are having here, they are having m plus n. So m plus n, gamma of m plus n numerator. Now let us talk about the denominator. यहाँ पे denominator में देखिए x का कोएफिशिएंट इधर denominator में आ रहा. अब now you see here in place of x variable we have z now. Z का कोएफिशिएंट क्या आ रहा है यहाँ पे 1 plus x. So it will be 1 plus x and the power यहाँ पे जो power है वही power as it is रहेंगे. यहाँ पे n है then it is n. If you have m plus n you will get m plus n. तो अपना difference किधर किधर आ रहा है I'll write it here. Our difference is like this, m plus n. Instead of n we have m plus n. Denominator variable अपना z नहीं है, variable अपना 1 plus x है अभी, 1 plus x and then this power will be m plus n again. Okay, that is our answer. That's it. And actually this is nothing but what, 0 to infinite. The multiple terms I wrote into the denominator, 0 to infinite x power n minus 1 by 1 plus x whole to the power m plus n value. You know the second property of beta function?
Yes, sir.
So with the help of the second property, I wrote that value will be equal to, actually we proved yesterday 3 properties now. Beta of m comma n is equal to beta of n comma n symmetric property. Second property, beta of m comma n is equal to integral 0 to infinite x to the power of n minus 1 by 1 plus x to the power of m plus n into dx, or which can be written as 0 to infinite x to the power of m minus 1 by 1 plus x whole to the power of m plus n into dx. And also the third property, integral 2 times of beta of m comma n is equal to 2 times of 0 to pi by 2 sine theta to the power of 2m minus 1 into cos theta to the power of 2n minus 1 into d theta. That is the third property. These 3 property of beta function, 6 properties of gamma functions we have completed. One more property of gamma function is left off. I told you yesterday we can prove it later on after the relation. So relation is over. I am going to prove that the 6th property, gamma of 1 by 2 is equal to root 5. वो proof कर रहा हूं अभी. See the next page. Mahmood, give me the answer. Mahmood, I want your reply. Not only Mahmood, all students I want. Aziz Khan, Mahmood, all 3 sisters. Tanzila is there in the class. CR of girls CR.
Yes, sir.
No, you are not giving any answer. Did not understand maybe.
Yes, sir.
Join late.
Yesterday's first class.
Yesterday class is related to today's class. Now prove that this is the last property of gamma function. Prove that it's also very, very important. Prove that gamma of 1 by 2, gamma of 1 by 2 is equal to root pi. Gamma of 1 by 2 is equal to root pi. Let us see the proof of this one. This is the proof. See how it will be. Just now we proved relation between beta and gamma function. I'm using that. We know that gamma of m into gamma of n by gamma of m plus n is equal to what we proved. Tell me. It is beta of m comma n, relation between beta and gamma. Just now we proved. Call it as equation number 1. Also, by the third property of beta function, what is the third property? 2 times of 0 to pi by 2. 2 times of 0 to pi by 2. Can you tell me anyone? Sin theta to the power of 2m minus 1 into cos theta to the power of 2n minus 1 into d theta is equal to beta of m comma n. Beta of m comma n. And a third property of beta
Ji,
function.
sir.
See, we joined these two, equation number 1 and equation number 2. If you compare, what do you say from 1 and 2? From equation number 1 and from equation number 1 and 2, both values are beta of m comma n values. So both of them are, what do you say? Both of them are equal now. 0 to pi by 2. 0 to pi by 2 sin theta to the power of 2m minus 1 into cos theta to the power of 2n minus 1 into d theta is equal to, here what we are having, gamma of m into gamma of n divided by gamma of m plus n. So now we have a special substitution, then with the help of that easily we can prove. Gamma of 1 by 2 proof karna hai. So what I am going to do it here is put m is equals to 1 by 2 and n is also equal to 1 by 2. If m is equal to 1 by 2, can we say that after cross multiplying 2m minus 1 value is equal to 0? Can we say cross multiply? Similarly, 2n minus 1 also is equal to 0. When substituted these values here, 2 times of 0 to pi by 2, 2 times of 0 to pi by 2, sin theta to the power of 2m minus 1 value will be 0, means it is 1. Any number power 0 is 1. Similarly, this is also 1 into d theta. Okay, correct? Yes. Yes, give me the answer. Okay, gamma of m value is 1 by 2. And similarly, one more, gamma of n value is also 1 by 2 divided by m value is 1 by 2. N value is also 1 by 2. 1 by 2 plus 1 by 2. So 1 into 1 is 1 only. 2 times of integral 1 d theta is theta between the limit 0 to pi by 2. 0 to pi by 2. This is equal to gamma of 1 into gamma of 1 is gamma of 1 by 2 whole square. Gamma of 1 by 2 whole square divided by gamma of 1 by 2 plus gamma of 1 by 2 is nothing but gamma of 1. This is equal to, this implies that 2 times of upper limit minus lower limit. Upper limit is pi by 2 minus lower limit is anyhow 0. I am not writing. This is equal to, already first property of gamma function, you remember, gamma of 1 value is equal to 1, already we proved.
Yes, sir.
Yes. So this is gamma of 1 by 2 whole square. Whole square. This 2 and this 2 will be cancel it out. The square we bring that side. It is becomes root. Root pi is equal to, it's a gamma of 1 by 2. We proved the 6th property of gamma function and this will be completed. Yeah, any doubts? How many properties are there, Sheikh Rehan? There are 6 properties in gamma function, 3 properties in beta function, total 9 properties and 1 relation. Out of this, you will get 1 LAQ, 1 SAQ. Okay. Now give me the attendance. Oh, second भी है, third. Students, give me the attendance now. Yeah, how many students are there? Roll number 1 is there. Give me the attendance, otherwise I'll mark as absent. Hello? Roll number 1 is there. Two, three,
Present.
yes, 4.
Present, sir.
Attendance 0, Papa. Oh, 4. 5, 6, 7. अटेंडेंस नहीं दी तो मैं एब्सेंट डाल देता हूँ, देखो 8.
Present, sir.
हाँ, Rehan, you are asking the doubt now. How many properties are there? 3 properties of beta functions, 6 properties of gamma functions we have. 9, 10, 11, 12, 13. महमूद 14.
जी सर.
महमूद आप क्या करिए, इसका स्क्रीनशॉट लेके भी मेरे को थोड़ा भेजा दीजिए, दो भी काम एक साथ हो जाता.
जी सर, ठीक है.
14, 15, 16, 17, 18, 19, 20.
20 present, sir.
Yeah, Mahmood, yesterday you are there,
Yes, I was there.
not given the attendance.
आप screenshot लेके दिए थे.
Okay. 21.
Present, sir.
Yeah. 22. 22. 23. 24. 25. 26. 26 is there, no? Not there. 27. 28. 29. 30. 31. 32. 33. 34. 35. 36. 37.
Present, sir.
Yesterday you are not there, no?
Yes, sir. In the morning session.
Okay. 38. 38 is there. Yeah, 39. 39. 38 is also there. 39 is also there. Okay. 40. 41. 42.
Present, sir.
42 is there. Okay. Away is big. 43, 44, 45.
Present, sir.
अभी तो ऑनलाइन में तो तीनों की भी आवाज आना, ऑफलाइन में तो देख के बोल सकते हो. 46, 47,
Present, sir. Sir,
46.
46.
46, Umar Ali.
Yes. Yes.
Okay. 47, Aziz Khan abhi nahi uthe hoंगे. 48, 49,
Present, sir.
49 is there.
Yes, sir. Present.
Okay. 51, 52, 53, 54.
Present, sir. 53.
Yeah, 53. Okay. 54, 55, 56, 57, 58, 59, 60. Okay. Okay, students, thank you. If we have another, हाँ बोलिए.
सर 35 प्रेजेंट सर
35 present है. Okay, 35 का attendance डाल दिया हमें.
सर रोल नंबर 29 प्रेजेंट है उनका माइक अनम्यूट नहीं कर सक रहे.
Okay, right, no problem. ठीक है.
Thank you.
29 का भी डाल दिया हमें. Okay, so end of the session. If we have another class, I'll inform you before. Okay, thank you.